Okay, our second competitor of the afternoon is Kristof Cank from Chemistry and Biochemistry, using fungi to treat brain-eating amoeba infections.
I want each of you in this room to think about the last time when you went to a water park for swimming. Was it a happy memory? I'm sure it was. But in 2016, for the 18-year-old Karen, that was her last happy experience in her life. She went on a rafting trip with her church group and got infected with a really serious disease. Just in 2 days, she passed away. That wasn't the only case happened across the United States. From the 1960s to 2017, out of the 143 cases, only 4 individuals survived. The organism, the amoeba, is called the brain-eating amoeba. It does exactly what it sounds like. The amoeba lives in fresh water, infects humans through their nose, travels to their brain, and then feeds on their brain tissue. It causes a really rare but rapidly fatal human brain disease, which leads to the patient death in less than 2 weeks. Case numbers are emerging, and children are at the biggest risk. What is even worse is that this disease has no cure. My research group is focusing on finding a molecule, one single compound that could potentially cure the infection of the amoeba. Secondary metabolites are tiny little molecules that fungi, plants, and bacteria are producing to help them survive environmental challenges or to defend themselves. We are looking after these molecules with fungal origins. We have a collaboration with a company called Microsynthetics, who represents over 55,000 fungal isolates. We also have a collaboration with the University of Georgia, who does the biological screening for us. We have screened over 4,000 different fungal samples to find the right molecule. Now, because fungi produces tens and hundreds of compounds per species, we have to find the right species and we have to find the right molecule. I would describe my work as finding the needle in the haystack. In order to do that more effectively, we are using different magnets. These magnets are the tools of chemistry, biochemistry, analytical techniques such as mass spectrometry, which helps us finding the mass of the compound. To figure out the structure, we use a technique called nuclear magnetic resonance, which works as the same way as MRI, the medical imaging approach that doctors use to get a detailed image of an organ in your body. After finding these molecules from nature, we have to isolate them, purify them, and eventually solve the structure. By now, we have multiple leads. I want you to look at the image of amoeba one more time. Swimming is supposed to be a happy activity. The thought that brain-eating amoeba is floating all around you and your child when you're enjoying your weekend trip is devastating. My hope and my goal is that with this research, we are going to find a molecule. The molecule that can be a game changer, a drug candidate one day, that will take away the fear in your mind to enjoy water activities as it's supposed to be, without the risk of getting infected with an incurable disease. Thank you.